Hi Chris, this is just a little video to show you what we've done with your Barduino concept. I'm going to show you the finished board, and then I'm going to show you how your board goes together, because there's a couple of mistakes that need fixing. So here we go. This is a quick tour of your new board. Hi Chris, so here's your Barduino card. Just a quick once over to show you all the bits and pieces on it. There's the Max 7221. There's our 7-segment displays and the bar graph. Here's our Arduino chip. Here at this end we've got a little bit of signal conditioning. This will protect the Arduino from any excess signal on the input to the device, and your inputs go on the back of the card down there. The idea is that you can put a 0 to 5 volt signal, so you must condition the map signal to be 0 to 5 volts on here. And also on, as you can see, we've got components on the top and bottom of this card. The idea is that nothing on the front side of the board should be higher than the face of the LEDs, and that means that you can mount this right up against a window. On this side of the card we put some of the taller parts like the capacitors and the access connections for the serial port and the crystal, and back here the programming lead if you really need to get in, and the little LED on the back here is a magic LED that says I am being programmed. Quick demonstration of the board in action. This is obviously with 0 manifold pressure, and as I turn the control you see the bar increasing and increasing and increasing. I turn it back down again like this. And just to show you, one of my problems is I have broken my chip and it won't actually go any higher than that on the bar. The digits are still reading the input but the output isn't. Sorry about that, but that's what happens with an experimental board. Okay, so here is the blank board that I'm about to send to you. I haven't sent it obviously. 3 or 4 places where you need to make corrections to the board. Between this pin here and this pin here you need to put a link on the back of the board. This is the fault that caused the damage to my copy of the 7221. On the real board, that piece of white wire there makes that link. Next, which is fairly fiddly fault to fix, is these 2 lines for the serial programmer. If you see those two lines need crossing over so that pin 2 goes to pin 3, pin 3 goes to pin 2. That change might be easier if you put the programming lead on this side of the board, but you'll have to be very careful to make sure that the top of those pins doesn't come higher than the LEDs. It probably won't, but just do be careful about it. Next problem is here between pin 4 and pin 9. There should be a link in there. I didn't do that with a single wire because it's actually a ground connection, and really you're connecting between the copper there and the pin there, but the nearest place to get it easily is there. So link pin 4 and link pin 9. Incidentally, whilst we're on this side of the board, you can see some positions for surface mount components. These are 0805 sized capacitors here and here and here, and a single 10k resistor on these 2 hits here. What else is there in the way of screw ups that need fixing? There's the possibility, well, you will have to change this on your board. When I've been testing it, I've linked this 4th pin here to here so that the USB connection is providing all the power to the board. You won't want to do that on your Trans-Am board. So what you'll want to do is link up some parts around here to put out a 5V regulator on those spots, and then cut that link there, so that the board is only powered from external power and not from the USB. It's important that you don't try and run USB and system power at the same time, else you'll kill something, probably something expensive. I think that completes a very quick tour of the board, so if you have any further questions you better ask me by email.